Okay, the next concept we want to talk about in section 2.3 is local maximums and local minimums. And what these simply state is that over a certain interval or certain area, do we have a maximum or a minimum? So notice that this function does continue upwards in both spots. If I were looking in this area that I defined with these lines, is there a minimum? And this point, negative 1, 1, is what's called a local minimum. It is the smallest point in between these two x values. It's not the smallest point of the whole function, but it is the smallest point in that area. Likewise, the point 1, 2 is a local maximum. If I were looking at x between 0 and x is 3, that is the highest point between those. So that is my local maximum. It is not the highest point or the largest y value of the whole function, because it does continue up. But in this little area right here, it is the largest. Okay, now absolute. So here's absolute max, absolute minimum means for the whole function, it is the largest or the smallest value. So let's take a look on some examples over here. Okay, on this graph, so this goes from x is 0 until x is 5. It doesn't continue, there's no arrows. So we have a local or an absolute max right here. And we say the absolute max value is 6. And it occurs at x equals 3. So the maximum value is 6 of the function, and it occurs when x equals 3. We have a minimum, an absolute minimum value at, or minimum value of 1, and it occurs at x equals 0. So that's the smallest for the whole function. 0.44 is a local minimum, and 0.55 is a local maximum. But the absolute max and min are here and here. Same thing we're going to do on this one. Do we have an absolute max? Well, again, the function does not continue, so it's just this little segment. So the max value is 3, so it's the y value, and it occurs at x equals 5. Okay, how about an absolute minimum? So we want to say it's at 3, 1, but it's actually not. Notice that this is an open circle right here. That means that point does not exist in this function. So if it does not exist, there is no minimum value. Minimum value does not exist. And that does not exist because that point does not exist. Okay, on this one, they're all closed circles, so that's good. So our max value, and again, it means what is the y of the maximum, which is 4. Max value is 4, and it's at x equals 5. Min value, we do have a minimum value of 1. So min value equals 1. So min value is 1, and this is at when x is 1, when x is 2, and all those points in between. So we say minimum value of 1 at 1 is less than or equal to x, which is less than or equal to 2. So all the x values between 1 and 2 give us the minimum value for this function. Okay, fourth graph here, notice that this does have an arrow here, so that means it's continuing to increase. Thus, there is no absolute max value. So, no max value. Okay, our minimum, though, it starts at 0, 0, and goes up. So, min value is 0 at x equals 0. So, it's possible to have one and not the other. Perfectly okay. And let's take a look at this last one here. We have got, again, a function that's defined, though this one does have an arrow, so it continues upwards, okay? So we want to see, is there a maximum? Well, this is a local max, but the function itself continues, so there is no absolute max value. And for our absolute minimum, looks like it's right here, but again, this is an open circle indicating this point does not exist. So no absolute minimum. And I didn't write absolute in front of all of these because our instructions say find the absolute. So we're not looking for the locals on here. Okay, last concept, average rate of change. Just like the slope is the average rate of change of a line, and it doesn't matter which 2 points you calculate it from, we can calculate the average rate of change, so the average rate of change on a function between points A and B. And the way we define this is to say the average rate of change is the change in y divided by the change in x. Excuse me, there you can see that. So average change in y divided by the change in x. So to get this between, again, points A and B, we say plug B into your function and subtract the function when you've plugged A in it. So this is simply what is the y value at x equal to b, what is the y value when x equals a, all of that divided by b minus a. Okay, so let's see what it looks like so it's a bit easier to understand. So we've got this function defined as 3x squared. And I want to see what is the average rate of change when I go from 1 to 3. So I'm going to say a equals 1, b is 3. The smallest number is a, the largest is b. So my average rate of change, oops, that should be it, an x there, is the function of b minus the function at a divided by b minus a. So let's plug in everything here and hope that I have room. So the function is 3x squared, but I'm plugging in my b value, which is 3. So 3x squared. So this gives me f of b minus f of a. So again, the function is 3 times whatever the a value is, which is 1, squared. All of this over b minus a, so 3 minus 1. Okay, now we just have to simplify it to get a number, which is our average rate of change. 3 squared is 9 times 3 is 27. 1 squared is 1 times 3 is 3. And 3 minus 1 is 2. So that gives us 27 minus 3 is 24 over 2. So my average rate of change from 1 to 3 is 12. That's not the average rate of change for the whole function. This is where it's different than calculating the slope of a line. Okay, now we're going to try and calculate our average rate of change from 1 to 5. If this had been a line, if my function was a straight line, this rate of change would be the same as this one. But let's see if it's the same here. So I need to calculate f of b. So 5 is b, a is 1. So f of 5 minus f of 1 divided by 5 minus 1. So our function f is 3 times the input squared minus 3 times the input here squared over 5 minus 1, which is 4. Okay, it's just math. Don't be scared. 5 squared is 25 times 3 is 75. And we know that this is equal to a 3 over 4. So 72 divided by 4 equals 18. Okay, so that's what it looks like. We'll do one last one, and this is the last bit of the notes. So we're calculating to see from 1 to 7 what the average rate of change is. And we can abbreviate that average rate of change as ROC, so we may see that more often. So our rate of change here is going to be f of 7 minus f of 1 over 7 minus 1. So 3 times 7 squared minus 3 times 1 squared over 6. 7 squared is 49 times 3 gives me 147 minus 3 over 6 gives me 144 divided by 6, which is equal to 24. So notice how our average rates of change have changed. They've increased. That's perfectly okay. And they could actually change. One could be positive, one could be negative. That may happen too. But it's perfectly okay that they're different from each other.